This video is meant to accompany the 2-1 notes in Savvas Envision Geometry on parallel lines. Okay, so this is 2-1. Okay, our main goal is we want to be able to determine the measures of angles formed when parallel lines are intersected by a transversal. So parallel lines are usually denoted with arrows on the line, matching arrowheads. Like maybe we want to do 2. I could have another set of parallel lines, say, going this way. If I want them to be seen as parallel, I could put matching arrowheads on those. If we talk about one set of parallel lines, then a line that crosses a set of parallel lines, like this line here, we call a transversal. So these are the parallel lines. And then this one we call the transversal. This one over here is also a transversal. Another transversal. So we're going to focus on the angles that are made when you have parallel lines cut by or crossed by a transversal. There's a relationship. Hopefully we'll discover between the angles that are formed. Okay, let's move on. So here's our explore reason. This diagram shows 2 parallel lines cut by a transversal. What relationships among the measures of the angles do you see? Well, let's see. 1 and 3 are a pair of vertical angles, so those have to be congruent. And 6 and 7 are another pair of vertical angles that need to be congruent. Let's say angle 1 was 100 degrees. Angle 3 would be 100 degrees. What else could we say? Angle 2 would be 80 degrees. And angle 4 would be 80 degrees. And even though like angle 5 looks the same as angle 2 and angle 6 looks the same as angle 1, with this line in this transversal across this line, the best we can do at this point is go for like a linear pair being 180 degrees or vertical angles being congruent. But it does appear that angle 2 is congruent to angle 5. And it also appears that maybe 3 would be congruent to 7. We could also get like 1 with 6 and 4 with 8. They all seem to be the same measures. Maybe 8 and 2. 1 and 7. Let's see what else we got. And so on. Now, if a different transversal intersected these lines, like let's say we had a transversal coming across this way, would you expect to find the same relationships? Well, let's see. Again, these are going to be vertical. These are going to be vertical, so they're going to be congruent. And again, it looks like maybe those 2 would be the same. And since vertical angles means those have to be equal, we could say that these are the same. This one and this one looks like they would be the same because these are supplementary. So it doesn't look like a different transversal would make a difference with the relationships of those angles. Let's move on. What angle relationships are created when parallel lines are intersected by a transversal? So let's see. Identify the pairs of angles of each angle type made by the snowmobile tracks. Okay, so here we have 2 parallel lines. And then these snowmobile tracks cut across the parallel lines, and it's asking us to identify the pairs of angles that each type makes. We have a type of angle that we're going to call corresponding. And corresponding angles are same side, same side. They're the same side of the transversal line. So let's look here to the left. And the same side of the parallel lines. Let's look above. So angle 5 is to the left and above, and angle 1 is to the left and above the other parallel line. So we would say that angle 1 and angle 5 would be a pair of corresponding angles. Similarly, we could do the same thing with angle 6 and angle 2. These would both be to the left and below. So 6 is to the left of the transversal below one of the parallel lines. Angle 2 is to the left and below. So angle 6 and angle 2 would be another pair of what we would call corresponding angles. On the other side of the transversal line, we have, like to the right and above, we have 8 and 4. And we would also have angle 3 and 7. So these would all be what we would call corresponding angles if you have parallel lines cut by a transversal. Alternate exterior angles. Alternate, let's look over here, alternate exterior, we could interpret as alternate sides or opposite side of the transversal, outside exterior, outside the lines that are crossed. So opposite side, outside, we'll go with alternate exterior. Now let me erase this other stuff from the diagram here. So we're looking at this diagram. And now we're looking for alternate sides of the transversal line. So opposite sides of the transversal outside the lines that are crossed. So outside are going to be on this side of the parallel lines and opposite sides of the transversal. So angle 5 and angle 3 would be a pair of alternate exterior angles. As would angle 8 and angle 2. They're opposite sides of the transversal, outside the lines that are crossed. Corresponding angles, same side of the transversal, like both to the right and below, 7 and 3. Both to the right and above, 4 and 8. To the left and above, 1 and 5. To the left and below, 2 and 6. We would call those corresponding. Alternate exterior, outside, opposite sides of the transversal line. Okay, let's move on. Here's our postulate, postulate 2.1. This should probably be added to your list of theorems. And same side interior angles postulate. If a transversal intersects two parallel lines, then same side interior angles are supplementary. Now supplementary means they add to 180 degrees. Same side interior, inside, same side. So angle 1 and angle 2 would be same side interior. Angle 1 and angle 2. as would angle, say, 3 and angle 4. And it tells us this postulate is saying that angle 1 and angle 2 would add up to 180 degrees, and angle 3 and angle 4 would add up to 180 degrees. Okay, let's look at a demonstration here. Okay, here we have some parallel lines. Let me move these around a little bit. And what I've done is I've numbered the angles 1, 2, 3, 4, 5, 6, 7, and 8. So let's look at corresponding angles first. So here's one set of corresponding angles. Angle 1 and angle 5. Okay, same side to the left and above. So angle 1 and angle 5 are a pair of corresponding angles. And angle 2 and angle 6 are a pair of corresponding angles. Angle 2 and 6 are to the right of the transversal line, which is the red line, and they're both above the parallel lines. So these are 1 and 5 are a pair of corresponding angles, and 2 and 6 are a pair of corresponding angles. Now look at the measures of angle 1 and angle 5 as I change these angles a little bit. So what do you notice about 1 and 5? You should notice that they stay exactly the same. Look at angle 2 and angle 6, their measures, as I move this around. Angle 2 and angle 6 also keep the same measure. We're going to see that if you have parallel lines cut by a transversal, then corresponding angles are congruent. We have another set of corresponding angles, 8 and 4. 8 and 4 to the right and below, and 3 and 7. 3 and 7 to the left and below. So look what happens when I move the angles around, change the angles a little bit by changing the lines. Notice that 3 and 7 stay the same. Those are corresponding angles. And notice that 8 and 4 also stay the same measure. Those are also corresponding angles. Let's look at same side interior angles. According to the postulates, 3 and 5 would be same side interior, same side of the transversal, inside the lines that are crossed, and also 4 and 6. So let's look at angle 3 and angle 5. Let's change this around a little bit. So I drag this around. Notice that angle 3 and angle 5 change, but also notice that the measure of angle 3 plus the measure of angle 5 always equals 180 degrees, no matter what angle they happen to be. So this is a demonstration that same side interior angles are supplementary. 3 and 5 are same side interior angles, and they always add up to 180 degrees. We could do the same thing on the other side. Let's look at angle 4 and angle 6. Angle 4 and angle 6 are a pair of same side interior angles on the right hand side. Notice that the measure of angle 4 plus the measure of angle 6 also is 180 degrees. As I change the angles around, notice that the angle measures change, yet they're always going to add up to 180 degrees. So we can say that same side interior angles are supplementary. 4 and 6 are a pair of same side interior angles, and also 3 and 5 are a pair of same side interior angles. Okay, so if a transversal intersects two parallel lines, then same side interior angles are supplementary, which means they add to 180 degrees. Let's move on. So example 2 here, how can we express each of the numbered angles in terms of x? Let's see what we got here. One thing we can see is that angle 2 and angle x, if these are parallel lines cut by this transversal, 2 and the angle labeled x are supplementary angles, as are 3 and 8. So 3 and 8 have to add to 180 degrees, and angle 2 and angle x also have to add to 180 degrees. So let's see what they're saying here. The angle with measure x and angle 7 are vertical angles, so they have to be congruent. And angle 6 and angle 8 are also congruent to each other. And we can see that 6 and 7 form a linear pair, and x and 8 also form a linear pair. And since 8 is congruent to 6, we can say that, either way we go, these add up to 180 degrees. You can make conclusions about angle 1 and 3 like you did with 6, 7, and 8. The angles that are equal to x are going to be the corresponding angles, which are angle 1 along with x, and then by vertical angles we have angle 7 and angle 3. So if we start with angle x and angle 1 are in corresponding positions. We saw from the demonstration that corresponding angles are congruent. By vertical angles, angle 7 is going to be congruent to x, and also angle 3 is going to be congruent to 1. And here we have two angles, like 7 and x are congruent, and x and 3 are congruent, and 3 and 1 are congruent. X and 3 are actually what we would call alternate interior angles, and we can see that x and 3 also will be the same measure. Let's move on. Theorem 2.1, alternate interior angles theorem. If a transversal intersects two parallel lines, then the alternate interior angles are congruent. Let's look at the demonstration of that. So alternate interior angles, 3 and 6 would be a pair of alternate interior angles, and 4 and 5 would be a pair of alternate interior angles. So let's look at these alternate interior angles. Let me hide some of these others first. So let's show these alternate interior angles. So we have angle 5 is alternate interior with angle 4, and angle 3 is alternate interior with angle 6. Notice that 3 and 6 have the same measure, and 5 and 4 have the same measure. So I move the angles around. Notice that the alternate interior angles keep the same measures. 5 and 4 and 3 and 6 are congruent angles because they are alternate interior angles. If you have parallel lines cut by a transversal, alternate interior angles are congruent. Let's go back to the slide. Okay, let's move on. Our theorem 2.2, corresponding angles theorem. If a transversal intersects two parallel lines, then corresponding angles are congruent. Okay, back to our, let's look at our corresponding angles. We're looking at 1 and 5 as being corresponding, and also 2 and 6 as being corresponding. And notice that as I move the angles around, 1 and 5 are always going to stay the same measure because they're corresponding angles, and 2 and 6 keep the same measure because they're also corresponding angles. If you have parallel lines cut by transversal, corresponding angles are congruent. We could also look at the other sets of corresponding angles. We've got angle 8 and angle 4 are corresponding, and also angle 3 and 7 are corresponding angles. They're both, same side below for 3 and 7, and for 8 and 3, or for 8 and 4, they are same side and below. And as I change the angles, notice that the same 3 and 7 stay the same measure, and 8 and 4 also stays the same measure. So that's another pair of corresponding angles. So 3, 7 are corresponding, 4, 8 are corresponding, 5, 1 are corresponding, and 6, 2 are corresponding. Corresponding angles are congruent if you have parallel lines cut by a transversal. Let's go back to the slideshow. So this is our corresponding angles theorem. We will try to prove this in example 3's try it. Let's move on. Theorem 2.3, another theorem to be added to our list, the alternate exterior angles theorem. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. And we can kind of see where this comes about. If we look at 1 in this angle here, these are vertical angles. And if we look at 2 and the opposite angle there, those are also vertical angles. And we can see that if we have parallel lines cut by a transversal, we've already talked about alternate interior angles being congruent. By vertical angles, we can see that the alternate exterior angles also are going to be congruent. So 1 and 2 would be a pair of alternate exterior angles, and with the dots, these would also be a pair of alternate exterior angles. So if we have parallel lines cut by transversal, alternate exterior angles are congruent. Let's look at the demonstration. Alternate exterior angles would be 1 and 8 and 7 and 2. So let's look at 1 and 8. 1 and 8 should be congruent. 1 and 8 have the same measure, and also 7 and 2 are alternate exterior angles, and we can see that 7 and 2 also have the same measure. So as I move the angles around and change their measures, we can see that the alternate exterior angles keep the same measures. So alternate exterior angles are congruent if you have parallel lines cut by a transversal. That's our theorem 2.3. Let's move on. Here's a proof of example 3 proof. Prove the alternate interior angles theorem. So let's see what they did. We're given that M is parallel to N. Let me blow this up a little bit. We're given that M is parallel to N, and we want to prove that angle 1 is congruent to angle 2. So let's see how this proof needs to go. If angle 1 is parallel to angle N, we could say that 1 and 3 are supplementary to each other. And then also we have that 2 and 3 are supplementary to each other because those are a linear pair. And if 2 is supplementary to 3 and 1 is also supplementary to 3, then by congruent supplements, we have that angle 2 must be equal to angle 1. So let's see what they did. M parallel to N. They note that angle 1 and angle 3 are supplementary. That's same side interior angles postulate from the beginning of this unit, the beginning of this chapter rather. That means that if they're supplementary, they add up to 180 degrees. And angle 2 and angle 3 are going to add to 180 degrees because they're a linear pair. That's the angle addition postulate. And you can say 180 is equal to 180. So you can set these equal to each other using the transitive property. And if we take angle 3 away from each one of these, we're left with the measure of angle 1 is equal to the measure of angle 2. And that means that angle 1 must be congruent to angle 2. So when I talked my way through this, I was thinking about congruent supplements. 1 supplementary to 3 and 2 supplementary to 3, therefore 1 must be equal to 2. That was what we had last chapter, but also we could do the proof this way. So a couple of different versions of the proof that alternate interior angles are congruent if you have parallel lines cut by a transversal. So make note that the same argument would work going the other way. This angle with a single dot next to 1 and the angle 3 would also be alternate interior angles and would be congruent. If we go back to the demonstration, alternate interior angles, there we go. Angle, okay, these are numbered maybe a little bit differently. We've got 5 and 4 and 3 and 6 are the alternate interior angles. Notice that 5 and 4 have the same measure, and also that 3 and 6 have the same measure, and also we should be able to see that they are supplementary also. But we're just focused on the alternate interior angles being congruent. Back to the slides. Okay, so here's an example proof. Example 4. We want to prove that angle BAE, this angle here, is congruent to angle BCE, is congruent to this angle here. So we have parallel lines cut by transversal. That means these angles are going to be congruent to each other. May be useful. We've got a different transversal going this way, though, with these parallel lines, which means that these angles are going to be congruent to each other. And let's see. So let's see how they do this proof. So we're given the parallel lines. Oh, we're also given that BE is perpendicular to DF, and that angle AEB, this angle is congruent to this angle. So we got that these two angles are congruent. Mark those in purple. And we want to show that those two angles are congruent. So let's kind of see. Okay, so we got alternate. If we do the parallel lines with the transversal here, then let's see. We can't really do this with the right angle. So let's see how they do this proof. So they got the parallel lines and they have the perpendicular. They note that, let me get these marks out of the way here. They note that angle BED and angle BEF are right angles. That means they're going to be congruent. So they're equal to 90 degrees. The measure of AED and the measure of AEB adds up to 90 degrees, definition of complementary angles. And also the same things can go on this side over here. Angle BEC and angle FEC are also going to add up to 90 degrees. That's angle addition postulate. These make the right angle. Then they're going to subtract. Oh, we're given also that AEB is congruent to angle CEB. That's given. So AEB and CEB are the same angle. So if we subtract those off of the 90, basically we've got that AED is congruent to CEF. That's our congruent complements theorem. From our alternate interior angles theorem, we have BAE and AED are going to be congruent because those are alternate interior angles. And also BCE, which is this angle here, and angle FEC are going to be congruent to each other because of alternate interior angles with the parallel lines in this other transversal. And then by the transitive property, since BAE is congruent to AED, and since CEF is also congruent to AED, we can set those equal to each other, and that leaves us with BAE congruent to BCE by the transitive property of congruence. So here's an example proof. It's complicated proof, but we notice how we can use the alternate interior angles theorem. We've got congruent complements, and we're using definition of right angles. Let's move on. Okay, example 5, we want to find these angle measures. Let's see. So here's a barn, and we want to look for the relationships among these angles. Let's see what we have here. So so AC is parallel, we want AC which is this side here, to parallel to EG. So if we look at this here, we can see that angle 1 and angle F need to be supplementary. And also, if this is a 68-degree angle here at the peak of the roof, with this transversal coming across, 68 and angle 2 are going to be congruent because those are corresponding angles. And then using these parallel lines cut by the transversal, angle 2 and angle 3 are also a pair of corresponding angles. So with the parallel lines that I have drawn in here, 68 and angle 2 are congruent. And then using the parallel lines BAF or BH and AJ, angle 2 and angle 3 are also a pair of corresponding angles. So 68 goes with angle 2, and 68 also jumps down with angle 3. Angle 3 and angle F are going to be 68 degrees because that's a pair of vertical angles. Another thing we could have done would have been to look at the parallel lines going this way and this way, and we have the 68 and 1 would be supplementary. 68 and this other angle here, the other side of 2 would be supplementary. 2 would be supplementary to, and 68 would be supplementary, which means that 2 is also 68. And there's several different ways we could basically get that measure of 68 to equal those other angles. Supplementary, so the measure of angle 1, if this is 68 degrees, these are same side interior angles. 180 take away 68 gives us 112 degrees for angle 1. A pair of corresponding angles for 1 then would be this other angle here on the other side of F. This angle here would be 112 degrees also. And we got 68s and 112s sort of alternating around the diagram. Let's look at this triad. If the measure of EJF is 56, find FHK. So you get EJF 56. So E to J to F. This angle here they're telling us is 56 degrees. And they want us to find angle FHK. F to H to K. They want us to find, let me change colors. They want us to FHK, they want us to find this angle here. Let's see what we got. So we have parallel lines cut by a transversal this way. Here's our one of our parallel lines this way and this way. So our transversal line. So we got, this is a 56 degree angle. By corresponding angles, this angle here is also going to be 56 degrees. These are both above the transversal line to the right of the parallel lines that are crossed. By vertical angles, this angle here is also going to be 56 degrees. Blow this up more. Try to move it over. Let me get rid of some of these lines here. So this is a 56 degree angle we're given. And by corresponding angles, this is a 56 degree angle here. With these being the parallel lines, let me put the parallel lines in like this. Here's the parallel lines that we're dealing with. Here's our transversal line. See what we got. So if this is a 56 degree angle, by corresponding angles, this is a 56 degree angle. Mark it. So we'll mark the angles that are congruent. So these two angles are congruent. These are congruent by corresponding. These two are going to be congruent because they're vertical angles. Now if we look at the parallel lines, using this as the transversal, these are also same, these are alternate interior angles, which makes these congruent. Let's see what we need to prove. FHK. Find the measure of FHK. So here's FHK. So what we could do, even though they don't have it drawn in here, this other KD line here also could be thought of as a transversal with this set of parallel lines. So we have parallel lines cut by a transversal. These are going to be same side interior angles, which means they need to be supplementary. And so if one of these angles is 56 degrees, if we do 180 take away 56, we'll have the measure of angle FHK. So at the measure of angle FHK is 180 minus 56, which is 124 degrees. So that's how we can find the measure of FHK. Let's go back and look at the diagram again. So let me get rid of the markup. Kind of summarize what's going on here. So we've got that angle EJF is 56. EJF is 56 degrees. I'm going to just mark it as the congruent arc. Then we have with parallel lines and JC being the transversal. A, J, and B, H are parallel. JC is the transversal. That means that these angles are congruent because those are in corresponding position, which lets me say that this angle is congruent because it's a vertical angle. And now I continue these lines down like this. If we still use these parallel lines, but now we're going to use JC as the transversal line, and KD is also parallel to JC, BH being the transversal, like this. We have parallel lines, with this being the transversal. These are same side interior angles. These are going to be supplementary. If this angle is 56 degrees, this is going to be 180, take away 56. And that's it for the notes.